Hello everyone. So today in this lecture we will see exponential indeterminate forms, that is 0 raised to 0 form, infinity raised to 0 form and 1 raised to infinity form. Now let us see the rules for all the forms. For 0 raised to 0 form, rule number 1 is we can say that the given equation is in 0 raised to 0 form only if limit x tends to a f of x is 0 and limit x tends to a g of x is also 0. And our next step is to convert 0 raised to 0 form to 0 raised to 0 or infinity raised to infinity form. Now rules for infinity raised to 0 form. Its rule number 1 is limit x tends to a f of x should be infinity and limit x tends to a g of x should be 0. Then only we can say that given equation is in infinity raised to 0 form. And our next step is to convert this infinity raised to 0 form to 0 by 0 or infinity by infinity form. Now for 1 raised to infinity form. Again, rule number 1 is here also we can say that equation is in 1 raised to infinity form only if limit x tends to a f of x is equal to 1 and limit x tends to a g of x is equal to infinity. And our next step is to convert this 1 raised to infinity form to 0 by 0 or infinity by infinity form. Okay. So now let us see the examples of exponential indeterminate forms. Okay. So for that, here we consider example 1, limit x tends to pi by 2 cos x raised to pi by 2 minus x. Now, if we substitute this limit into this equation, then we get cos pi by 2, value of cos pi by 2 is 0. And here also we get pi by 2 minus pi by 2, that is 0. So this is 0 by 0, 0 raised to 0 form. Okay. And here note that before converting this 0 by 0 form to 0 by 0 or infinity by infinity form, we have to convert this 0 raised to 0 form to 0 into infinity form. Okay. And for that, so we can write this equation as log y. So we will multiply to get this equation into 0 into infinity form. We will multiply this equation by both sides by log. So we get log y is equal to limit x tends to pi by 2 minus x. So this term will come before cos x and here we will multiply by log, so log cos x. So we have to multiply it by both the side by log, so we get this term before cos x. Okay. And now to get 0 by 0 or infinity by infinity form, we can rewrite this equation as limit x tends to pi by 2 log cos x divided by 1 upon pi by 2 minus x. Okay. And now if we substitute this limit into this equation, then we get log cos pi by 2, 0 and log 0 is infinity. And here also we get, in the denominator part we get infinity, so we got infinity by infinity form. And as we got infinity by infinity form, we can apply L'Hospital's rule here. So we will first differentiate numerator part and then we will differentiate denominator part. So differentiating, we get limit x tends to pi by 2. Differentiation of log cos x is 1 by cos x. And differentiation of cos x is minus sin x. And in the denominator part, differentiation of 1 upon pi by 2 minus x, that is 1 by that is 1 upon pi by 2 minus x whole square, similar to 1 by x. Okay. So now this part will go into the numerator part. So we can rewrite this equation as limit x tends to pi by 2 minus x whole square sin x. Sorry, here minus will come because if we consider this term as 1 by x, then differentiation of 1 by x is minus 1 by x square. So similarly 1 by pi by 2 minus x, differentiation will be 1 upon minus pi by 2 minus x the whole square. Okay, so here we get, and this term will come into the denominator part, so that is cos x. Okay, so now if we substitute this limit into this equation, then we again get pi by 2 minus pi by 2, and then cos pi by 2 is 0, so we get 0 by 0 form. We get 0 by 0 form. So we will again differentiate numerator part and denominator part. So we get limit x tends to pi by 2. When here we will apply multiplication rule. So first of all, this term will remain as it is, and differentiation of sin x will be cos x. And when this term remains sin x remains as it is, we get this 2 will come before, so 2 pi by 2 minus x divided by minus sin x, because differentiation of cos x is minus sin x. Okay, and now if we substitute this value in this equation, then we get, here log y remains till the end, so write here log y. Okay, then we get pi by 2 minus value of cos pi by 2 is 0, and here also we get 0, and sin pi by 2, in the upper part we got 0, so answer will be 0, but here we get, here log y remains as it is, so log y is equal to 0. So in order to remove log, we write y is equal to e raised to 0. Okay, so answer of this question is y equal to e raised to 0. Okay, so example 2. Limit x tends to pi by 2 sec x raised to cot x is given. Okay, so now first of all we will substitute this limit into this equation, then sec pi by 2 raised to cot pi by 2, and value of sec pi by 2 is infinity, and cot pi by 2 is 0, so we get infinity raised to 0 form. Okay, now our next step is to convert this equation into 0 raised to infinity form before converting it to 0 raised to 0 or infinity raised 0 by 0 or infinity by infinity form. So we will convert it into 0 into infinity form, and then we will convert it to 0 by 0 or infinity by infinity form. So for converting into 0 into infinity. So for converting into 0 into infinity form, we will multiply both sides by log. So if we consider y is equal to limit x tends to pi by 2 sec x raised to cot x, then we will multiply both the side by log, so we get log y is equal to limit x tends to pi by 2. This cot x will come further before sec x as we multiply by log, so cot x into log sec x. Okay, and now if we substitute this limit into this equation, then cot pi by 2 is 0, and log sec pi by 2, that is infinity log. Okay, So we get 0 into infinity form. Now we will convert this 0 into infinity form to 0 by 0 or infinity by infinity form. So we can rewrite this equation as limit x tends to pi by 2 log sec x upon tan x. We can rewrite cot x is 1 by tan x. So we have written like this. Now if we substitute this value in this equation, then log 0 is infinity and 10 pi by 2 is also infinity. So we get infinity by infinity form. Okay. And as we got infinity by infinity form, we can apply L'Hospital's rule here. So we will first differentiate numerator part and then we will differentiate denominator part. So we get limit x tends to pi by 2. Differentiation of log sec x will be 1 by sec x. And differentiation of sec x will be sec x into tan x. And in the denominator part, differentiation of tan x will be sec square x. Okay. Now this sec x and this sec x get cancelled. So we get limit x tends to pi by 2 tan x upon sec square x. Okay. And now if we substitute this limit into this equation, then we get tan pi by 2 is infinity and sec pi by 2 is also infinity. So we get infinity by infinity form. So again we will differentiate numerator part and denominator part. So we get limit x tends to pi by 2. Differentiation of tan x will be sec square x. And differentiation of sec square x will be 2 sec x. And again differentiating sec x, we get sec x into tan x. Okay. Now, from this, we can rewrite this equation as limit x tends to pi by 2 sec square x upon 2 sec square x into tan x. But this sec square x and this sec square x get cancelled. So we get limit x tends to pi by 2 1 upon 2 tan x. And if we substitute this limit into this equation, then value of tan pi by 2 is infinity. So we get 1 upon infinity, and that is equal to 0. So we get log y is equal to 0. So y is equal to e raised to 0. And you all know that value of e raised to 0 is 1. So we can also write y is equal to 1. So answer of this question is 1. So now example 3, evaluate limit x tends to 0 a raised to x plus b raised to x plus c raised to x upon 3 raised to 1 by x is given. Now before we saw the examples of 0 raised to 0 and infinity raised to 0 form, so now we will see the example of 1 raised to infinity form. Here we will get 1 and here we will get infinity if we substitute this limit. Now let us see. If we substitute this limit here, then we get a raised to 0 plus b raised to 0 plus c raised to 0 upon 3. Value of a raised to 0 is 1, b raised to 0 is also 1 and c raised to 0 is 1. So 3 by 3, that is we got 1 here and here 1 by 0 is infinity. So this is the example of 1 raised to infinity form. Okay. Now our next step. This is a very important question. It was asked in GTU 2017, 2015 and many times. So it is a very important question. So please pay attention. So now and here, now if we substitute this limit into this equation, we got this form. Now we will convert this equation into 0 into infinity form. And here in the question it is given that value of A is 1, B is 2 and C is 3. Okay. Now to convert into 0 raised to infinity form, we get limit x tends to y equal to a raised to x plus b raised to x plus c raised to x by 3 raised to 1 by x. Now converting it into 0 into infinity form, we will multiply it both the side by log. So we get log y equal to limit x tends to 0. This 1 by x will come before this term. So 1 by x log of a raised to x plus b raised to x plus c raised to x upon 3. Okay. And now as we got 0 into infinity form, we will convert it into 0 by 0 or infinity by infinity form. So we can rewrite this equation as limit x tends to 0 log of a raised to x plus b raised to x plus c raised to x upon 3 upon 1 upon x. Okay, and this x will we have written in the denominator part. And now if we substitute this limit into this equation, then we get, here we get 0, 3 by 3 is 1 and log 1 is 0, so we get 0 by 0 form. Okay, and as we got 0 by 0 form, we can apply L'Hospital's rule here. So we will first differentiate numerator part and then we will differentiate denominator part. So differentiating, we get limit x tends to 0 3 upon a raised to x plus b raised to x plus c raised to x, and differentiating this a raised to x, we get a raised to x log a plus b raised to x log b plus c raised to x log c upon this 3. Okay, and how we got this term? Because differentiation of log x is 1 by x, so first of all we will reciprocate this term. So we got this, and then differentiating a raised to x, b raised to x, c raised to x, we got this term. Similarly, in the denominator part, differentiation of x is 1. Now this 3 and this 3 get cancelled. So we get limit x tends to 0, and this a raised to x plus b raised to x plus c raised to x will come into the denominator part. So we can rewrite this equation as a raised to x log a plus b raised to x log b plus c raised to x log c upon a raised to x plus b raised to x plus c raised to x. Okay, and now if we take this a raised to x, b raised to x and c raised to x common, then we get, if we now we will directly put this limit into this equation. So we get a raised to 0 log a plus b raised to 0 log b plus c raised to 0 log c upon a raised to 0 plus b raised to 0 plus c raised to 0. And anything, if we put this a equal to 1, b equal to 2, c equal to 3 here, then also we will get answer of anything raised to 0 will be 1. So here we get 1 plus 1 plus 1, that is equal to 3 in the denominator part. So we can write 1 by 3, and here also we get 1 value. So 1 by 3 log a plus log b plus log c. Okay, here log y will remain as it is. Here log y is there. Okay, so we can write log y is equal to log ABC raised to 1 by 3. This part will go into the upper part. So we get y is equal to, if we remove log from both the side, we get y equal to ABC raised to 1 by 3. Whenever addition term will be taken into the multiplication term, this term will go into go up. Okay, so we got log ABC raised to 1 by 3. And now if we remove log from both the side, we get y equal to ABC raised to 1 by 3. So answer of this question is y equal to ABC raised to 1 by 3. Okay. So now these are the examples for practicing of 0 raised to 0, 0 raised to 0, infinity raised to 0 and 1 raised to infinity form. Okay. Now you all have to do this 5 sums and also answers are given in the bracket. So you can verify whether you got correct answer or not. Okay. Thank you everyone. I hope you all liked my video lecture. Thank you.